All right, so on Friday, we started our one-to-one property with exponents because we're going to use that one-to-one property in a couple different ways. But basically what we said was that in order to solve these, we have to change them so the base would be the same. So if I'm looking at 21 and I've got 2 to the 3 minus x and then 8, which one do you want to change? The 8, good. So 8 would be 2 to what power? And then as soon as those bases are the same, you set the exponents equal to each other. So 3 minus x would equal 3. Subtract the 3. Negative x equals 0, and x would equal 0. Easy to check this one. If I plug that back in, I get 3 minus 0, which is 3, and then 2 to the third is 8. Questions? Yeah. Okay, and then 25, same concept. You have to change them so that the base is the same. This time I'm changing which one? The 4. So 4 becomes 2 squared. That's raised to the x minus 2. And that equals 2 to the 3x plus 3. So then on the left, I'm going to distribute this 2 to both. I'd get 2x minus 4 equals 3x plus 3. I want to subtract the 2x. Negative 4 equals x plus 3. And then I want to subtract the 3. And x is negative 7. Yep. Sure. Questions on those? Okay, so the wording on these is a little different than if you were to just get one individual question. One individual question, it would say something like, find the amount of money in the account or earned at the end if you invested. This one would have been $4,000 at 9% for 10 years. And then this would be compounded annually, semi-annually, quarterly, monthly, daily, and then obviously continuously. So you've just got to know that the end may not be given to you like that. You'd have to know what those mean. But let's just say I'm just going to pull the quarterly, okay? I'm going to pull that one. Yep. Well, your numbers are going to be different than these. Yeah. Okay. So the formula is P times 1 plus R over N to the NT. And the P is how much you invested, which is $4,000 for this one. 1 plus the rate is 9%. We have to put it in decimal, so 0.09. The number of times a year, if it's quarterly, would be 4. And it would be raised to the 4 times the T, the number of years, which is 10. And then you type that all in your calculator, and then you got to round it. So when it says near a cent, it means like a cent as in dollars and followed by cents. So you keep 2 decimal places there. So this one would have been 9740.755. I want to round it to the cent, which is the second one. This 5 bumps that up. So it would be $9,740.76. So be careful with your rounding because obviously that's something that it has to be perfect. Like you've got to be able to round it to the right thing. And then the only other difference, like obviously the number of times a year changes for the other ones, but continuous is our PERT formula. P times E to the RT. So 4,000 E 0.09 times T, which is 10. And 4,000 times E to the 0.09 times 10 was 9838.412. That 2 drops off. And I keep it at 41 cents. Any other questions from the homework? All right, 5.2 is called logs. So we're going to do this over the next 2, maybe even 3 days. We're going to do it kind of like we did with the exponential functions with graphing and then using what's called the one-to-one property or converting from logs to exponential or exponential to logs. How many of you have ever seen logs before that you know of? Okay, that's what I thought. So the biggest thing is that the most important thing is understanding the conversion between the log form and the exponential form. So log, and it literally will say the word log, it's shortened for logarithm. And it means that I can take something that's written in log form and switch it to exponential or vice versa. So if I had the one on the left, if it said y equals log base a of x, that's how that's read. Base is the little number, the subscript number, okay? When you convert it, the little number or the base on the log comes over to the other side of the equal sign. It picks up that as its exponent, and then the log drops off, leaving what's left. So if it's y equals log base a of x, the a picks up the y, it becomes a to the y, equals, the log is now gone, and what's left is the x. And you'll see this done with variables, you'll see this done with numbers, you'll see this done with a mix of those two. So let's just say it said 2 equals log base 3 of 9. So think about how they got there. The 3 comes over, picks up the 2, 3 to the second, and then it drops off, and it leaves it with 9. So if you think about log expressions like high school relationships, they never stay together. The two partners always separate. Okay, not yours. I'm sure yours will last forever and ever and ever and ever and ever. But most high school relationships separate, just like the log. So whether you're going from log to exponential, so if I went from log to exponential, or I go exponential to log, the partners never stay together. So when I go from exponential to log, if I take 3 squared equals 9, the base on the exponential part is the 3, right? That's what that spot is called. It becomes the base on the log. The base on the log is the subscript. And then the partners separate. The 2 goes to the other side of the equal sign, and the 9 joins the 3. These will be true statements if they're all numbers, and if they're not, then we're going to learn how to solve them. But like, let's say I had 5 squared equals 25, and I want to write that in log format. It's log, the base on the exponential function is the base on the log. The 25 comes over here now, and the 2 gets bumped to the other side. This is like one of those things, I feel like logs are like for those people that love mental math and they don't like to do a lot of work. This is sometimes their niche because you can do a lot of this stuff in your head. And the faster you get and the more you can understand the conversion from log to exponential, the easier everything will be moving forward. We're eventually going to do a lot with these, but for right now, we're just going to be converting and simplifying. All right, so this one says convert from log to exponential or vice versa. So we're just doing the conversion. You don't even have to do the math yet. Log base 2 of 8 equals 3. The 2 comes over, picks up the 3, drops off, leaving the 8. Go to 2. The 1/2 goes over, picks up the -4. So 1/2 to the -4 equals 16. 3, 10 to the 5th equals 100,000. Now we go back the other way. So this is the one we just did. 5 to the 2nd equals 25. That's log base 5 of 25 equals 2. Five, 3 to the -4 is 1 over 81. So log base 3 of 1 over 81 equals -4. And 6, 3/4 to the 0 equals 1. Log base 3/4 of 1 equals 0. All right, so these are some common properties of logs, okay? And these help with, again, like those little, it's almost like shortcuts. you can work it all the way out, or you can kind of memorize these and know how to use them. The first one says log base A of 1 equals 0, because anything raised to the 0 power is going to be 1. So if I were to see this side, the goal would be that I could look at that and know that it's 0. The only way to get 1 as an answer, and that big one would be the answer you would get by raising it to the exponent, the only way to get 1 is to raise it to the 0 power. So if I had log base 50 of 1, that answer is 0. And there's no way to get it by like breaking it apart into its factor tree. That's one of those properties you just have to know. So in order to get 1 as an answer from exponential, your exponent would have to be 0. If the base and the number next to it are the same, then my answer is 1, because the only way to keep something the same would be to raise it to the first power. So if it said log base 50 of 50, that answer is 1. So if the base and the big number next to it are the same, then it's 1. If I have a base and then next to it is being raised to a power and those are the same, then my answer is just the exponent. So if it said log base 5 of 5 squared, my answer is just 2. Just the exponent on the 5. And then the last one is the one-to-one property with logs. On exponential, we say if the bases are the same, we set the exponents equal to each other. For log, we say if the log and the base on the log are the same, then we set what's next to it equal to each other. So if I had log base 5 of x equals log base 5 of 2, then x equals 2. I ignore the log, and I set what's next to it equal to each other. Questions so far? All right, so let's see how many of these we could do. Some of them you're just converting, and then you might have to use your change of base, and some of them might be the mental math, okay? Starting with 7, I'm going to convert first. I would say 2 to what power gives me 32? And if it's not something you know off the top of your head, you're going to break it down. So 32 is 2 and 16, which is 2 and 8, 2 and 4, 2 and 2. And that is 1, 2, 3, 4, 5 2s. So 2 to the x equals 2 to the 5th, and x equals 5. Questions on that one? Okay, then I go to 8. Log base 4 of 2 equals x. So 4 picks up the x. 4 to the x equals 2. Now here's the long way around this one. Change 4 to be 2 to the 2nd. That would be raised to the x. The exponent on the 2 is actually 1, and then I can set these equal to each other. 2x would equal 1, and x would equal 1/2. The shortcut is if I need to square root something, I make its exponent what? If I want to square root something, it's the same as saying that power to the 1/2. So if I want to square root 4 to get 2, because that's what it would be, then my x equals 1/2. So if I had 25 to the x equals 5, then x is 1/2. If I want to square root the base, I make the exponent 1/2. If you don't remember it, then you do that long way around. But obviously that's going to be a shorter cut. Go to 9. So 3 to what power gives you 1? Zero. Good. Questions so far? Okay, go to 10. So 10 to what power gives you 1 over 100? Good. The negative moves it to the bottom, right? And then the 2 squares it. So you could reverse this. I could take the 100 and move it up. And then change it so that it's -2. But the short way is to say, how do I get this to the bottom? That's a negative. And then 10 to 100 is 2. So x is -2. So the negative moves it, right? So like if instead of me making this side equal this side, if I kind of think, how do I get the 10 to the bottom? That's my negative. And then how do I go from 10 to 100? I square it. And then you get the 2. You could use the 1-to-1 property. It just takes longer. All right, 6 to what power gives you 1? 0. 5 to what power gives me 1 over 125? Good. The negative moves it. The 3 changes it from 5 to 125. All right, log base 7 of 343. So 7 comes over and picks up the x. 7 to the x equals 343. Now you might know what that is, but you might have no idea, which is why we can break it down. So if we break down, 7 goes into 343. Four times and then 9 times. And then 49 is 7 and 7. So there are 3 3s, which means 7 to the x equals 7 to the third, and x is 3. So if you do not know, you use the factor tree. All right, go to 14. So this time x to the third power equals 8 over 27. Again, the better you get at this, you'll kind of be able to do a lot of this mental math process. But for now, we're saying I need to raise something to the third power that's going to make it a fraction, which means whatever x is has to be a fraction. So I could find it by reversing it. I could cube root the 8 and I could cube root the 27. What's the cube root of 8? 2. And what's the cube root of 27? 3. And 2 to the third would give you 8. And 3 to the third would give you 27. Go to 15. 4 to the 5 halves equals x. Now what happens when my exponent has a fraction? What number slides over to be the index? Good. Bottom slides over, so this becomes the square root of 4, and then the 5 becomes the exponent. Square root of 4 is 2, and 2 to the 5th. 2 times 2 times 2 times 2 times 2. 4, 8, 16, 32. Okay, looking at 16, so 49 to the x equals the cube root of 7. How do I make that cube root an exponent on the 7? I can rewrite this as 7 to the 1/3, and then I can rewrite this as 7 squared raised to the x. So then 2x equals 1/3. Divide by 2, or multiply by a half, and x is 1/6. Log base 5 of 1/625 equals x. So 5 raised to what power is 1/625. So the first thing I know is it has to be negative because it has to move it to the bottom. And then I have to break this down if I don't know it. So 5 goes in here, 105. Nope, 125. And then 5 goes in there, 25. And then 5 goes in there 5 times. So that is 1, 2, 3, 4 5s. So this is like the same as saying 5 to the -4th. So x equals -4. (10 to the x equals 0.001. So now there's two ways to look at that. One is change it to a fraction if you want to. Okay, so if it's 0.001, this is 10 hundred thousandths. So this is 1/1000. Or you could think of it in terms of like scientific notation. However many times I have to move my decimal, which if it's here, and I want to move it so that it's 2 in front, I'd have to go 1, 2, 3 times, and that would be left, which means -3rd. The other way is in the fraction, the 10 has to go to the bottom, so that's the negative part, and 1, 2, 3 zeros means it's 3. So 10 for each 0, that's 1 power. If it's 10, it's to the first, hundreds to the second, thousands it's to the third. You literally can just count your zeros. Still good? All right, look at 19, sorry. X equals log base 8 of the 4th root of 8. So if I want to write this, the easiest way to do this is rewrite 8 to the 1/4. And then remember, if the base is the same as what we're raising to the power, my answer is just the power. So this would be x equals 1/4. That's the shortcut, if you could see it. If not, then I'm doing 8 to the x equals the 4th root of 8. So then 8 to the x equals 8 to the 1/4, and then the exponents are set equal to each other. So totally fine to do it either way. (20) says x equals 3 log base 3 of x. So again, shortcut here is this base is the same as this base. I literally can ignore the whole thing and grab the 8. The other way to rewrite this is that 3 becomes the base on the log. So log base 3 of x equals what's left in the exponent, log base 3 of 8. And then the one-to-one property says x equals 8. So this is technically exponential. Even though that exponent has a log in it, That is exponential. The big number becomes the base on the log, and then you separate it out. What it's equal to goes next to it, and what it's next to goes to the other side. So if it said x equals 2 to the log base 2 of 5, let's say. The 2 here becomes the base on the log. These two separate. This comes on the side with the 2. So then it would be log base 2 of 5, and then x equals 5. But that's a lot of work when you don't need it. You literally could just grab if the base on the exponential function, so if the big number is the same as the base on the log, you literally can cancel it out and keep what's next to it.
So x just equals 5.
Yep, x would just be 5. You're welcome. So what's 21?
9.
Yep. All right, go to 22. So x to the negative 2 equals 25. Now, what to the negative 2 would equal 25? This is where it's weird. What's a negative going to do? So this is the same thing as saying 1 over x squared equals 25. Good. The negative means it would move it, right? So 5 would have to be there. And I'd want to move it to the top. So that's where the negative on the exponent comes from. So negative 5, if it's in the bottom. Actually, no, sorry. This you could cross multiply. X squared times 25 equals 1. And then divide by 25. And x equals the square root of 1 over the square root of 25, which is 1/5. So there's a couple different ways to do that one. I could have cross multiplied like I did. I could take this from here, 1 over x squared equals, and it would be 1 over 5 to the negative 2. Like you could do it that way. And then your 1/5 would be the one that's got the sign. So to move it, you would make it negative again. I think the cross multiplying is the easiest. Like move that x to the bottom and then cross multiply. All right, 23. 4 to the third equals x. What's 4 to the third? What's 4 times 4 times 4? 64. Okay, I think we're going to do this last one, and then we're going to stop here today. Yep. 4 to the x would equal the cube root of 16. So if the cube root, what would be the exponent of a cube root? 1/3. So 16 to the 1/3. Now at least I'm in exponential. And then can I rewrite 16 as a power of 4? It will be 4 squared raised to the 1/3. Now the base is the same, so I set the exponents equal to each other. X equals 2 times 1/3, which would be 2/3. Questions so far? All right, so I actually have to tweak the WebAssign. I'm gonna go in there right now and change it a little bit so that you can do that. Just the stuff that we've done today will be on the WebAssign. There's some stuff on there right now that we didn't get to, but I'm gonna stop here, okay? Some of the wording on WebAssign, it'll say like find the log of something where it's log of X and then it gives you X. Just take it and I'll show you what I'm talking about in a second. All right, so there's only one question on the homework tonight that says to use the graphing calculator it says use a calculator to evaluate the log. Okay, so we're gonna practice that one, but that's it. The rest of them you're gonna keep exact. You're not gonna use the calculator. When it says something like this, first of all, log by itself without any base is actually log base 10. So that's the same thing. Log is log base 10. Tomorrow we're going to get into something that's ln, which is log base e, but that is your given. So when you find the log button on your calculator, that is log base 10. So if it says log base 2 of 3, you can't use that button because that button is log base 10. Okay, we're going to talk about how you do a change the base with this one. This you will not do on your calculator. Anything that says log or log base 10, you're going to do. So if you have your calculator with you, if you'll find that log button, it's the fourth one up on the left. You're literally going to do log. This time it says x is 13.5. And you should get x equals 1.1303 repeated. So the instructions are going to say you use a calculator to evaluate log at the given value. It says find f of x equals log of x, and then it says x equals something, and then all you do is plug that in. So you're doing log of that value. If you've got it with you, check it. Make sure you're getting 1.1303. I forget what it says to round to, but just pay attention to whatever it says. Yep. You can't on that. So you have to do log base 10. That's what there's a formula to use. Log is log base 10. Yeah. Some calculators give you the opportunity to change the actual base. Most of them do not, but I'm going to teach you a change of base formula that you can use.